Welcome to Team Build 2010, from build definition to custom workflow activities in 75 minutes. My name is Brian Randall. I'm a senior consultant with MCW Technologies. I'm also an ALM MVP for Microsoft. I've done variations of this talk since the 2005 release, and in fact, Martin Woodward, who's a good friend of mine, works at Microsoft now. We've gone back and forth on some of the content in here. So I'm really happy with the story. I think we've got a really great product. This is one of those magical third releases for Microsoft, right? You know, the going lore was, you know, you never install a new version of the OS, you wait for the service pack. And when you're looking for when the product really hits their stride, right, the third release, like Windows 3.0, right, that was an epic moment for Microsoft in 1990, right? That was the point where they really pushed over the edge in the marketplace as the dominant desktop operating system, moving over from DOS, right? That's really where we saw the switch. And so with the 2010 release of Team Foundation Server, we get a new version of Team Build. So what we're going to talk about today is 0 to 60. How do you use and deploy Team Build, why you do it, and how do you do things like customizations. Now, the key thing to understand about using Team Build is to understand what it's doing. It's doing build automation. And so when we think about what is, let's talk about what it's not. Right? Build automation is not F5. Right? Just like unit testing is not F5. Right? Having a powerful interactive development experience in something like Visual Studio fakes us out from what the whole build, test, deploy workflow should be, right? I can recognize from some of you looking in the audience just by your hair color and bodily features that some of you have been around a while. So remember the days where, you know, you did your editing in some kind of text editor and you submitted a job to get a compile done, right? And then you got to try it out, right? Now this interactive debugging stuff. And of course we can talk about RPG, COBOL, various JCLs, all sorts of good stuff. So since we know it's not F5, what is it? Well, Martin and I came with this idea that it's Kava. Collecting, assembling, validating, and auditing. The idea is that number one, you want to collect all of the assets at the current point in time that make your application up. So in the beginning, that might not be very much. You might be lucky enough to be able to compile out a DLL and an EXE, right? Or maybe a couple web pages in a DLL. But when we think about production applications, most of our production applications are made up of many things, including supporting files like XML files, config files, maybe some local database storage. If it's a server-side database, maybe you got the T-SQL definition. So fundamentally, we have all that. We might have documentation. We might have installer programs. All those things need to be known. And you know, I was talking to Martin last night at dinner, and they recently put out a great book on Team Foundation Server. And so the story they used was really good. I really like this, so I'm going to steal it without shame. Martin said I could. But if you read the book, you'll recognize this. So imagine you're getting a new house built. And you've got the piece of land, and it's going to be built from scratch. And so you go and talk to the builder, they say, okay, we're getting started. Great. And this is like a user when you've sat down and you got the specs done. You said, we're ready to start building. And you've committed to a delivery schedule when they're going to have access to the program. Depending upon your organization, users may or may not get early releases, right? You might have a pre-release or maybe not. But imagine you having this house built. And so you come by a month later, and all you see is dirt. And you talk to the builder, oh, no, we're making great progress. It's going to be great. Come back another month. No, I'm telling you, it's awesome. We're doing great. Don't worry about it. It's going to be fantastic. So now you're getting worried, right? Third month. You know, we're supposed to move in next week. Don't worry, trust me. In fact, why don't you come by on Thursday? Great. So you come by. And all of a sudden you're amazed because there are people swarming all over the place, right? They got this dropped-in house, all these pieces, they're putting it together, right? And they're working hard, and you're watching the clock tick. You're watching the clock tick. And now it's getting to the evening, but they got the lights out. They're doing it. And so you come by Friday morning, and they hand you the keys, and they go, enjoy. And you walk in, you kind of look at it, that looks a little crooked. You walk in the room, and that paint doesn't look right. And Wait a minute, there was supposed to be a room here. Did you tell me where we could get that room? Right, the great room? Well, we ran into some issues. That's how your users feel with software, right? When you don't deliver something till the bitter end. And that's what happens when you build complex software today, right? The days of building the monolithic giant single EXE are gone. And so when we have multiple developers working on multiple pieces in isolation, we fail to understand what it's going to be like when we bring it together. So what we want to do is do this as soon as possible. We want to start doing team builds from day one, even if it doesn't build anything, right? Or build anything that does anything. Because as we get functionality in there, we now know where we're at every day. So we collect, and assembling is the compilation phase. We need to have that. But now that we've built it, how do we know it's of proper quality? Right? When we think about the house being dropped in, right? Every new house owner should get the opportunity to do an inspection before you accept delivery of the house. And that's where you go in and you have them fix little mistakes. Right? Hopefully, if you've been coming to the site and watching them build, you've seen some of the majors missing. Okay? But the point here is we want to validate what we've built. And this is our testing phase. This is where we, number one, want to run what we often call BVTs, or smoke tests, build verification tests, where we go through and we do automated testing, where it might be things like automated unit tests. It might be coded UI tests in the case of TFS 2010, where we have a program that's pretending to be a user, literally stepping through a test script. And then finally, we're going to audit those results. This is where you look at your checklist and say, is this good enough? Right? I was lucky enough to move into a new house about 6 years ago, and we went through. And it was pretty good, but when I got to the first day walkthrough, I said, I am not signing off on my house. And I have a weird setup where I have a 2-car garage and a single car like this in a weird L shape. And long story short, the roll-up door for the single car wasn't in. So they wanted me to sign off on the house, because like, oh, well, you got a warranty and all this stuff. I'm like, no, I am not signing off on that house. Well, the thing is, if I don't sign on the house, my loan company would not give them my money. But they were trying to convince me it was okay. No, we'll take care of it, trust me. No, sorry, I will not sign off until I get my door. And so the auditing phase in your build is when you go through and you look and say, okay, did things pass? Do things work? And did we get all the things we need? For example, in the beginning when you do a build, you might not have an MSI being generated. But to hit your release milestone, you have to have that because that's how it's going to be deployed for your users. Or you have to have the web setup script or the database deployment script, whatever it is. So the whole point of this is that build automation is going to help you answer the tough questions. Do our bits create a product? Right? At a certain point, you will have had enough inertia in your development effort to where you can start the application up and at least see the first page, the first screen. And then you'll start doing more with it. And at a certain point, users actually would take delivery of what you have. But the other thing it tells you is, are you on schedule? Right? Because when you start seeing things, you believe it. Right? So the developer always says, just give me another day. Just give me 5 more minutes. Now, 5 minutes, okay, I'll give you those 5 minutes. Any developer tells me that they don't want to show me what they're doing, and they ask for another day or another week, I do an intervention. Step away from the keyboard. Let's get in there and see where you're at. Is our product of high quality? Right? Developers will often say, I'm done. Yeah, I'm done. And you go, so you're done. Well, yeah, I just got to do this, and I got to change these hard-coded paths to be dynamic variables, and I got to do a couple things here. Right? We really want to know, are we done? And done means, yes, not only have you written the code, but it passes our quality gates. It's something that we know the user will accept. So ultimately, we're looking for build automation to make it trivial to take the pulse of our team, to know how we're doing collectively. So in Team Build 2010, right, this is the build component. It has a long name, but we always call it, most of us just call it Team Build. And today it is a core feature of Team Foundation Server. You don't buy it on its own. And it can run both on server operating systems and client operating systems. You can even run it on a virtual machine and get creative and spin up agents on demand. And this really is industrial strength build automation in the 2010 release. Right? It has the capabilities to orchestrate very complex build implementations. And what we'd like to think about is this is providing that F5 experience for your team. Hello, there we go. All right, I'm going to show you the config I'm using here today, and then I'm going to go and show you how to create a team build. So the idea is that a developer using Visual Studio is going to queue up a build. How you do that, there's multiple ways, I'll show you. And what happens is Team Foundation server will get that request, and it will pass that off to the registered build controller for that project collection. So if you're coming from 2008 or 2005, there's some new nomenclature here, right? Project collections are an intermediate entity between a Team Foundation server and team projects now. So a Team Foundation server has one or more project collections, and a project collection has one or more team projects. Footnote, most organizations only need one active project collection. So God forbid you're in an organization where you have 10 project collections. If you are, I'm guessing you're probably doing something wrong. And I'll be happy to argue with you after. Project collections were primarily created for the hosters so that you could have multiple companies or customers sharing a server but having isolation. So with this project collection, we have a controller, new architecture. Controllers manage and orchestrate one or more build agents. And it's the build agent that does the actual collection of your source and other assets, the compilation, and then if you're going to run tests, depending upon how the tests are set up, it might communicate with what's called a test controller, and they'll go forward and run tests. And at the end, your build report is published back to Team Foundation server, and you can look at the details. So let's switch over to my machine. Now, my machine here is running Windows 7, and that's one of the great things in Team Foundation Server 2010. I can run a local copy of Team Foundation Server and even build on my local laptop. So if we take a look at my Team Explorer window here, you'll see that even though I'm running Windows 7, I still have access to builds and work items. And if we go into my main folder, I have just a little client application. And the client application isn't very interesting. It has a big button that anybody with a forehead can use, and you click the button. And what it does is it tells you the version number and name of the client DLL it's using. And that's going to be important for later demo. Okay, so nothing too exotic. Now, if I want to build this, what I need to do is tell Team Foundation server I want to build it and what I want it to do as part of the orchestration process. So to do that, you come over to Team Foundation server, go to the builds node, right-click, and say new build definition. Now, what will happen is when you go to create the new build definition, they will look and say, hey, do you have an open solution? If you have an open solution, I bet you want to build that. Good thing to know that is your build definition can build multiple solutions at the same time and can even build across team projects. Okay? But you're stuck in one project collection, right? Because of the scope of project collection to build controller. Okay? Now, put a name, demo live at ATL. Okay? Now, trigger. In trigger, you'll see that you have lots of choices here. Okay? So you can do manual, which is what I'm going to start with. Then we have support for what's called continuous integration. Continuous integration is the process that every time a developer does a check-in, and that check-in is of something that is relative to the monitored portion of source control that the build is set to build from, it will automatically kick off a build for you. The power of continuous integration is that you're getting constant feedback about how your product comes together. And what this means is this is how you discover when a developer in one part of your team changes, for example, the public interface of a component that another piece of code is using, and that can get broken. And the general rule with continuous integration is you hook up some device that alerts the team when the build fails, everything from bright red lights to sirens to noise. And then there's a lot of shame that goes with breaking the build. And that shame can involve having to buy donuts for your team the next day. Or I broke the build hat until someone else breaks the build. So fundamentally, though, we're trying to not shame our fellow developers, although sometimes we do. What we really want to do is know, did that last change cause us a regression? Did it cause us to go from a known good, which was we build together now, to where we don't now? The next step is, hey, you've got a larger environment, and if everybody's doing CI check-ins, you're just going to have so many builds. So you can say, let's build every 5 check-ins. Let's build every 10 check-ins. And then we have gated check-in, which I'm going to show you, which is a new feature in 2010. and then you can build on a schedule. Now, workspace is actually critically important. And the problem is, they have to guess at what you want. They don't know all the pieces that are necessary for your build to execute on the server. And since the build agent is going to go to your version control repository to pour code out, it defines what's called a workspace, which is a mapping between the repository and the location on disk where it's going to do the actual compilation. It points to the trunk of the team project from where your solution comes from. That means it works out of the box, but it also means that as your repository gets larger, your builds get slower and require more disk space. To the point that, hey, the build broke. Oh, you broke the build. No, wait a minute, it's not my fault. Build server's out of disk space. Oops. So you really need to come in here and adjust this. And this is going to be critical to do also if you keep, for example, common DLLs in a different team project. And you want to use those specific versions. Right? Because it's only knowing about things that are at the trunk. Now, the build defaults that you pick the controller that you want this to execute under. And then it says, hey, this build produces output. It produces information that we want to put somewhere for people to look at. Right? Common reason you want to make the output available to testers. Now, even if you're doing this on a local machine, you're always going to do it in the form of a local, a UNC path. So in this case, I use localhost. And I've already got a folder set up, which is the name of my machine, drops. And then when you put this path, one of the things you can do is you can leave it like this. But if you do, and you do some builds, what happens is you end up with a folder that is the name of your build definition, and then underneath it, the different builds. Now that may or may not work. When you have a lot of builds, you're probably going to add a couple additional subfolders. And the nice thing is you can just put them like this, and they'll take care of the rest for you. That just gives you greater segmentation. This is particularly useful if you're doing branches and you're doing branch-specific builds. Okay. At this point, I'm good to go. The last option that's available is the process option. Now, because I had a solution open in Visual Studio, they picked that up as the item to build. And you can see if I zoom in there, it says build ATL build demo with default That's default platform and configuration. If you expand it, you'll see you have the option here to do configurations to build. And you can come in here and customize and say you want to build debug and release builds, okay? Or if you have custom build definitions in Visual Studio. And of course, this is where you can come in and I can add additional solutions that I want to build. And they'll build in the order defined in this dialog. Now, lots of other great things in here. For example, automated tests now are by default set to run tests and assemblies matching test. If they have the word test in it, the runtime will go and load them up, and it will use a little bit of magic reflection to say, hey, I see you're a managed assembly. Great. Now the question is, are you a managed assembly that has any test instruments for me to execute? And if it does, it will go through and run those automatically for you. Then we have the build number format. This build number format is used as part of the output folder name as well as for your label. What happens is anything it pulls out of the version control, it will label with this build ID. And that makes it possible for you to go back and find those particular sources. With the footnote that labels are not audited, and thus if someone deletes one, you won't know that they did. So you gotta be careful with labels. Clean workspace, there's just some advanced options. Code analysis. If you're using one of the versions of Visual Studio that supports code analysis, they will run it based upon the settings in your solution and thus projects by default, but you can say, you know what? I want you to always run it regardless of what the settings are. And then we have a new feature that's awesome, source and symbol server settings. You no longer have to fire up and get the Windows SDK and dig out the bits for source server and all that stuff, and index server. It's just taken care of for it. And what this does is this assists you when you're trying to debug an older build. It will map out to get the source from TFS and able to load the symbols up for debugging automatically. And notice index sources is turned on by default, and then for the path to this publish the symbols, once again, it's this UNC path format So in this case, I create a folder. And now it will copy the symbols when I publish the build up there. And then we have advanced, which has a bunch of other stuff. And does anybody build Silverlight? If you build Silverlight and you're building it on an x64 build server, there's this little option here for MS Build Platform. You want to change that to x86. Otherwise, today, your Silverlight build will fail. Okay? And I'll talk about some of the other stuff in a bit. So we'll save this. And now, we'll queue up the build. When you go to queue up the build, you still have the ability to adjust per build parameters. So you want to do some tweaks. Maybe you want to pass a custom MS Build command line switch, whatever you want to do. You can turn off on this build that you don't want to output to symbol servers, etc. And you can control things like the priority in the queue. Now what's going to happen here is when I queue this up, I can monitor the build run live. And you'll see we have this nice WPF interface, so I can zoom it up for you. And what you'll see up here on the top is that it's running, it's updated the build number, it's creating the drop location, and it's done. Just simple build, WPF app, doesn't take that long to run. So now I have this build that I can run anytime I want on demand. All I have to do is come in here and I can edit the build definition and change that to be something like continuous integration. What I could do though is if I have the power tools installed, which I highly recommend, I could right click on this and say clone the build definition. And what it just did was copy that definition for me, so now I can rename this by going into the edit option, and we'll change this to be ATL build demo CI. And then I'll go to the trigger, change that to continuous integration. And now what will happen is, when I go to my solution, and we'll go over here to some source. Make a change. I'm going to check in that change. And I can also associate with the work item I have here, and I'm going to mark it as associate. I'm going to check it in. And if we go over to the Team Explorer, notice there's a build running. And notice the glyph is slightly different. It's showing you that that build was kicked off by a check-in. And if we go take a look at the completed, there we go, and it's done. Now, continuous integration is a great feature, but there's one problem with it. When you start having larger teams, the possibility that a human, a developer, is going to screw up and break the build is pretty high. Now, like I said, you might want to keep that process in place because it gets you your donuts for the next day. The problem with that, though, is when you have a very large team and the build gets broken, you start doing some math. And when you crack certain numbers, like at Microsoft, when you have, thousands of people checking in, and if you just break the build once a year, how often is the build broken? Every day. So Microsoft introduced a feature called a gated check-in. And the way a gated check-in works is it takes the changes from the developer and puts it on what's called a shelf set. A shelf set is a feature that's been in place since 2005 where it lets you take your pending changes and put it up on a slot, a shelf on the server. And what they do is they put it up on the shelf set on the server, and then the build agent does a get latest, but then it pulls down the shelf set and smacks it right on top of the latest changes. And it does this build. If the build succeeds, then they take your shelf set and they check it on with a new permission that's in the system. They check in on your behalf. So the check-in is done under your ID, your alias, but it's only done if the build succeeds. If it doesn't succeed, you still have the pending changes in your workspace, and you got to figure out what happened. So let's go over here and duplicate the build definition. We'll edit it up, and we're going to copy this one, gated. Now what I'm going to do over here to ATL build demo CIs, I'm going to turn off that. And we'll go to the trigger, and we'll change this to gated. So let's clean up my windows. Go back over here. And now, let's do something silly, like get rid of the semicolon. Now, you would never do this, right? You would never make a change and not even just compile it locally, would you? No, never. Oh, phone ring, yeah, yeah, milk, yep, kids, yep, okay, yep, all right, thanks, bye. Oh man, I gotta get out here, gone. Oh, wait, check in, right? So now what's gonna happen is I go to check in. Quick change, my favorite. And now I get this dialogue that says, whoa, hold on, partner. We just want to know that your changes aren't going to be submitted yet, so you can't go tell them you're done. We're going to take a look at what you did, put it up on the server, and give it a go first. So we'll select build changes. Once again, a little bit of a different glyph there. You see a little folder. Dun 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 dun. I'm a sad person, right? I broke the build. So at this point, my changes did not succeed. I know I broke the build, but luckily I won't pay the painful price of being shamed by my fellow developers and ultimately causing pain to my team. So I have to go back over here. The change is still in my source code. So I'll put the semicolon back. I'm going to save this. I'm going to check it in. I'm going to get that same dialogue. And notice they even installed my comments here and my associated work items. Yes, go ahead. We'll let this run. And by the way, up here you see that this build is so far running faster than the previous build. And then now we'll see it ran. And you'll notice that it took longer to run, but it's now green. And so you'll see your last 7 builds there in kind of a little graph, which is nice. Not during the talk, it's okay. Now, if we take a look, notice the file is still checked out. I still have a checkout glyph on it. Well, what's happened here is they've checked in the changes on the server, but my workspace still has my pending changes. Now, there's a couple ways you can deal with this. One is if you go to the build report yourself, there's an option for reconcile workspace. When you click it, it'll say, hey, you want to fix all these pending changes? Yes. And now if we go in, you'll notice I have the lock glyph and I have my change. Now another thing you can do is that when you install Visual Studio 2010 Professional or higher, they automatically install the Team Explorer client, which is great, no separate install. But they also give you the Build Notifications Power Tool, or what was formerly the Power Tool. It's now built in. When you start this up, you're able to check current build status as well as go to options and control how you want to be notified related to builds. And you can basically show notifications from build triggered by yourself or by anyone, and you can see queue status started and finished. Now my builds run so quick, the notification thing isn't even worth watching. But it basically just pops up a toast at the bottom, it'll show you the status. And it turns out that when a build completes, it also will provide you with the option to reconcile your workspace. And that's nice when you don't want to have to go monitor things. You just want to go do something else, maybe go get coffee, come back, you'll see that toast, you can click that and go forward. So it's whatever works for you. So that's a kind of a quick tour of all the core features that are available. Now, this is a simple, I want to build everything on my app tier. We generally don't recommend this, right? Build activity is going to cause a lot of I/O to the server to get your source files on anything unreasonable project, as well as the I/O for generating builds, etc. Now, once again, I understand sometimes that's all you have, fine. But you can build a richer implementation where you have the build controller defined on your Team Foundation server, but you run the build machine as a separate machine. And this is a typical recommendation. When you get it on a second machine and you do the install, they'll recommend that you have at least 2 build agents. And you basically can adjust the agents based upon the speed of the spindles, providing disk access, your network, and how many processor cores do you have available. Okay? Going further, you can have multiple build machines. So if you have a large build environment where you have lots of team projects and one team foundation server, right? You can dedicate the agents. In addition, you can control through tagging what the agents are used for. So you can specify that certain agents know how to build certain products that require maybe third-party products that require dongles, for example. Okay? Or maybe it's a machine that's configured specially to talk to an external resource like your mainframe or some other legacy system. Right? And that's something you won't have to duplicate across all your farm because maybe it's just one team on one team project that needs that feature. So what you're able to do is you can go into the build agent definitions. So go back to my machine. And we manage our build agents primarily now from an administrator's point of view from the administration console, although I can do some of it from Team Explorer. And if I go over to my build configuration, you'll see on this machine, I have a single controller, and you also can see, of course, the status, and then I have 2 agents. This machine's got enough RAM, got enough cores, so it's perfectly fine here. And if we come in here and look at the properties, you'll see that you have this tagging option. And when you go add a new tag, it's simply a way to say that, hey, this is a server that supports building Java, for example. Okay? Or supports our legacy system. And then once we've done that, we can go in and you can go to your build definition. And if we go down here into the process and go down in advanced, you notice there's an agents setting option. And you'll notice that tags, if we expand, we can play with the tags filter. And then notice I can say I want to build on the Java agent. Okay? So this provides you a way to have large implementations where you have specialized build servers. Another reason to have multiple build servers is from a security perspective. Different organizations have different rules, right? Some of you may work for an organization where, hey, you're a developer, party on. You have access to everything. I did work for a company actually here in Georgia, and they have very specific rules. If I didn't know better, I think they're doing something illegal, but they work for the banks, that's why. They break up the work for each company they do work for. They don't have the name of the company. A company has an ID. And only the team that works for that company knows that the ID translates to a particular customer. So they have dedicated separate build servers per team project, and each team project is identified by the numeric ID. And so they have to keep things separate. So they use security inside TFS, and by having multiple build agents, they completely separate that process. And same thing with their drop shares. They drop stuff onto restricted share. So when you have that type of setup, you have lots of flexibility. The other nice thing about this is you start getting to end of release cycles, where you're going to be building more often as you're going through your bug bashes and you're doing those last things to say, look, if we can get these last 5 bugs fixed, we can ship. And so you want to do is get those builds going as much as possible. But one of the things you do is when you have that type of change is you want to make the distinction between one build and another. So by having multiple build agents, you can build it. The other one can get builded at the same time, particularly longer builds. And you're not in a forced function to wait as long. And you can go hardcore. And the only reason you need this type of configuration is if you have multiple active team project collections. Now, the critical aspect about this here is that you cannot do this config in a single machine environment because you can only have a single build controller installed on a machine at a time. So if we go back a few slides and look at build on app tier, this is the most common setup I see, this and this setup here. In these two configurations, you'll notice that the collection is bound to the controller on the same machine. The minute you get to a second collection that requires that you have a second machine to run, at a minimum, the build controller. All right? And so those are, like I said, the exotic implementations. So as I mentioned in show, you have this new controller agent architecture, agent tagging. We use the new TFS administration console to do the core management. Now, by the way, this administration console, when you install build on another server, is made available. So, for example, if you choose to install team build on your local Windows workstation, you can involve that in the build process. You can kick off builds and have it build on your agent. We have gated check-in. right? Gated check-in, once again, is that let's do a build up on the server first in isolation before I let your changes get into version control. And then we have this big change here for Windows Workflow as our build, or what really is our orchestration engine. MS Build still does the compilation, but Windows Workflow does all the extra stuff. We're going to dig more into that in a second. And then finally, there's a feature specific to lab management. Is if you're using the new lab management feature that's available with your Ultimate or Test Professional license, you can build virtual labs, virtual machines, and the build definition that's available there will take the output of a build, and it can hook up to a virtual machine environment, which is one or more virtual machines, and it can do things like snapshots, take your build, deploy it, do more snapshots, do automated deployments and automated tests, all from a monster build definition. And I'll show you what it looks like, but it's pretty ugly to say the least. Now, we've improved the management overall, right? So in 2005, you could do command line deletion of builds, but you had to manage your drops manually. In 2008, we have a GUI to do some managing, and that's still there, and I'll show you that. We also had retention policies in 2008. And this will go through and clean up the output of your build as well as the supporting artifacts. But what's really cool in 2010, we have the ability to be more specific about how we want things cleaned up. And the key to understand about 2010 having these new features like lab is that lab management can produce a lot of other artifacts. In particular, it produces snapshots for virtual machines. So you literally can be chewing through gigabytes of data on a per build basis. Okay? So this adds to the things you have to be aware of if it's your job to do the care and feeding of your build agents and the artifacts that go with them. So let's just take a look at a couple of these things so you know where they're at. So let's cancel out of that. So if we come over here to builds, you'll see that you have some options here for new build initial. You can manage your build controllers here. You can come over here and you can disable them and get to those edit boxes so you don't have to use the console all the time. Manage your build qualities. These are the default build qualities that are available. So the standard workflow, if you're buying into build seriously, is that someone has to have the responsibility to check the results of a build and mark the quality. Now, you can just take the built-in stuff, which is, hey, if it's green, go for it. If it's red, don't, right? You might have just a very simple Boolean definition in your organization. Microsoft, for example, though, goes and rates the quality of their builds. And rating the quality of the build, they're basically saying, well, hey, it compiled, but looking at our BVTs, you know, we had only 75% pass rate. And so what they'll literally tell you is that this build, for example, I'm doing work for the team on Visual Studio, I might have to go pull a build of Visual Studio. And I know that, hey, I can go use, say, I don't know, the new Visual C# features, but maybe the C# plus SharePoint integration isn't working in this build very well. So it'll tell me that rating, and what you do here is you assign the build quality from this drop down here. And so you can change what those are, and the nice thing is then people can go to that list and say, hey, is this something I should use? This is particularly useful when you have the distinction between it was initial test pass, which is BVTs, versus a lab test, versus, hey, it's ready for initial test, and I want the testers to go through and do their manual test suites. Because what you're looking for is to get to a point where this build has significant meaning. Is it something that we are ready to share beyond the development team and the test team? Right? The other hand is even ready for the testers, right? Sometimes you don't want to waste the testers' time. You've got a new build here, but if our automated tests aren't going good, they're not going to get very far on their manual tests. Okay? And, oh, yes, this one, security. You can control lots of options. Most importantly, the ability to delete builds and delete their artifacts. Right? Destroy builds. Oh, that's always nice. You can also control who can start builds. Right? I was talking to a woman on Sunday in my workshop, and that was one question she had. Yes, you can have it so that only developers can start build, but testers can't. Right? Or you can set up that you have build masters. Microsoft has what are called build labs, and they have people that their job is to control builds. So the average person, unless it's based upon a gated check-in or a CI build, doesn't control building all of Visual Studio. Okay? It goes through a particular process. A particular engineering effort is applied to that. And so you have that control in your Team Foundation server. Okay, so I want to make sure I was going to tell you about something specific. Oh, retention policies. So if we come over here to a build definition, and look at retention policy, this is where you can control how long you want to keep them and what you want to do about it. So if we go look at the output for my builds, for my CI builds, go look at completed, and I have lots of filter options here. If I want to get rid of this, I can right click, and first of all I can say, you know what, keep this indefinitely. That means regardless of the, retention policy kicking in and saying it's time to delete this build because it exceeds 10 of these build types, this is a special build. We want to keep this. Okay, and that prevents auto deletion. But if I do decide to delete, I have a lot of choice about what I delete. So first of all, notice lots of details that are stored inside TFS. The drop folder, this goes and cleans up your drop folder, assuming you haven't done stuff already. Test results, this could be a big one, right? When we talk about automated builds using lab management, I can have out of the box 2 full snapshots created. Now, if I have an environment, which remember is a collection of 1 or more virtual machines in a typical config, right, I literally can be chewing through 10 gigs per build, right, depending upon the size of your virtual machines, how much memory is allocated, how many changes are affected. So that's what you can control, is that you say, you know what, I want to keep the details so my reports still have that information. I still want the output, but I don't need the test results anymore. Same thing with the label. Do I want to keep the label in source control? Often you want to keep that because you're going to delete the output of the build, but you'd like to make it easier to try and get the point-in-time source code at that setup. And then finally, symbols. Do you want your symbol share cleaned up? Okay, click delete. And now if we go out and look, right, I don't have any output left in my CI folder, right? It's gone. I'm going to take questions at the end just because I got limited time, but I will take your questions afterwards. I'll walk with you, I'll talk with you. I'm not going anywhere today, so I'm happy to, and I'll give you my email and everything at the end. Okay. And I'll try and get done a little bit early in case people want to ask questions at the mic. I'm supposed to give you guys a few minutes there. Okay, build notifications. So built into TFS is an eventing service. They did some work in 2010 where it's more efficient. At the end of the day, for builds built in, we basically can know that a build was kicked off and a build was completed. And we have these email notifications that are tied to that. So you can get an email notification when a build is finished. This is good for managers who want to monitor status of the team and they don't want to be constantly going into the Build Explorer to look at the build status. Okay? And then the notification tool, as I mentioned, is built into your Visual Studio install. You just turn that on and it'll pop up status notifications on how your team's doing. The one thing they haven't put in the product is a status dashboard. That's a pretty popular thing in a lot of the Agile communities, and I know people that have built them, but right now Microsoft does not ship one in the box. Now, in 2010, right, we've had this evolution of how things worked. In 2005, MS Build 2.0. In 2008, MS Build 3.5. And then you'll notice what's happened in 2010. Workflow is taken over as the orchestration engine, and only assembling, that building stage, is using MS Build. Now, the reason they did this is because MS Build was never defined to be an orchestration language or function. It's very powerful because, yes, I can create a .NET class, implement the appropriate iBuild interfaces or inherit from the abstract base class, and party on. I can create custom tasks. The problem with that is that, let's see, the debugging experience, not the best, right? And just the whole format of the way the build execution executed, it wasn't linear for people, and it didn't have branching the way they thought it should work. And so it was difficult for most people to grok. So moving forward to workflow with a visual designer is meant to be better. And it's one of those things that I'm happy and unhappy at the same time. You'll see why in a second. Now, the way this works is that when you go and define your build definition, you pick the build process template, which is a XAML file that is checked in and defined inside your team project automatically. So when you do new team project from Visual Studio, what you'll find on that new team project, and let's just do one, prove a point. So let's say File, New, Team Project, Live ATL Build, Demo for the folks at TechEd. Hit Next. Next, I just finished. Okay, give it a second. It's going to go through and create the new team project. And what we're going to find inside source control is I'm going to have a new folder. And the new folder is going to have 3 XAML files in it by default. Oh, of course not, it couldn't be created. Why? Because I have a gated check-in. It's trying to complete a build? Nice. I missed something there. All right, well, anyway, source control, I've already got it here. Build process templates. This is one I'm going to show you a customization. These 3 right here, however, are built in. Now, these XAML files then, in workflow XML syntax, describe what you want your build to do. So you see there's 3 there: default template, lab default template, and upgrade template. Pretty straightforward then. Create a new build, you get default template. If you're upgrading a Team Foundation Server 2008 server to 2010, they will take all your existing build definitions and upgrade them to use that template, and then they will point to your original metadata that you had before so that your existing customizations continue to work. Now, they can't guarantee that they'll work perfectly, but at least you'll have all the work done. You just need to basically run the builds then after you upgrade your server and then see if anything went wrong. And then finally, lab default is the default orchestration workflow when you have lab management and you create a workflow build. Now, the way this gets chosen then is you come over to your build definition, go to the process, and you'll see it's right here. This tells you what you're editing. And what happens is if you click the drop down, you get the combo box that allows you to change and select a different one. So for example, if I pick lab default, things go away, and I get this option to run the wizard. But then it says, sorry, Brian, you don't have lab management installed and configured. Okay? So there's nothing really to show you there. That's simply a wizard that lets you set up that process. Okay? So I'm going to close this and say no. Now, talk about the upgrade template, right? Allows you to continue to use your TFS build.proj file. Okay? But other than that, this is not something you're going to want to use. Now, when you start thinking about defining builds, right, you start thinking about, well, what kind of builds do we need? At a minimum, you should have daily builds, right? A build that you execute every point in time at the same time, right? A lot of organizations have a cutoff window, right? Any change you want in today's build has to be in by 5 o'clock, because at 8 o'clock we're going to run the build, okay? And a lot of this depends on the resources that are necessary for your build to completely run from start to finish. Like I said with Microsoft, their builds are often very large, right? Windows can take days to build, right? To do a full end-to-end all the stuff they do, okay? And so if you're doing automated builds that require a lab, you might have to set the window so that way by the next morning, testers, for example, can come in and find that their test environments are ready to go. So we want daily builds, right? Use continuous integration with, gated check-in so that you can check your pulse more quickly. That said, continuous integration gated check-ins is a more mature type of behavior for a team, right? So start simple, just do the dailies. You also might make the distinction of having weekly builds, where a weekly build does more additional work, a lot of your regression suites, okay? The other thing to do is create integration builds. If you're using branching and merging, one of the things that has to happen is you get to a point in a branch and you say, hey, we've got enough work that we want to push to another branch. Well, the question is, how do people know what's in that build? Well, one of the things that happens is when you're going through and checking in work, you can associate change sets with that work. So for example, if we look at some of the work I've done earlier, I've manipulated a work item called My Tasks. If we look at the links then, I have these various change sets. And when I double click on the change set, I can see the stuff I checked in, and I see the bidirectional link back and forth. This information will get registered in your build report. The way it works, however, is that it doesn't start tracking change set associations until you've had your first clean build. Then every time you do a build, it goes through and says, from the last time I ran this build till this point in time, I'm going to associate and gather all of the change sets and all the work items that were associated. So if we come over here and take a look, now the thing is I've done a bunch of different builds, so let's do this. Let's go look at my CI build history, or my gated history. So I've got 2 there. Let's say I had 1 good one. There we go. And what you'll see there is that I've got associated change set 16 in task 1. Now what's going to happen is every time I run that build, it's going to pick up whatever it was. Well, the problem with a gated check is I'm only seeing a 1 for 1, right? Or 1 if I associate multiple work items. I'm only going to see that limited window. When I'm doing the integration, though, I'm probably pushing changes for 4 or 5 days worth of work from my team. So what I want to do is have an integration build, such as this on-demand build, that I only run in between points. So you see this one right here called on-demand working. Right, if we look at its history, I've got 2 there. But I haven't run it since I've been doing the work here. So let's queue up this build. Turns out that this is doing, so this is using my customized template. Give it a couple seconds. And then notice how it's got change set 16 and 15 on it. So I did extra work in between from when I ran it, because I ran it before I came in here, made sure everything was working. Then, while you guys are watching, I've run a couple builds, I've done a few check-ins, and I've caused 2 change sets to occur. So it says, well, since I ran the last build, the beginning of the talk, you've done 2 check-ins. So there's 2 change sets. Now, let's say I do a few more and I run the build again. I will see that same set. So what you do is you get your build set up in your various branches. You should have at least 1 integration build per branch. And what that'll allow you to do is you run it the minute you get the branch set up, and then you run it every time just before you want to do your integration. It will collect then every change set and every associated work item since the last time you ran it. So let's say you create the branch on Monday, and you do check-ins for 5 days. You run the build again on Friday, you will see every check-in in that branch for the week. And the branch, what's scoped and what shows up in the report is relative to whatever gets built. So the solution or solutions within the branch is what you want to have that build executing. Now, what's great about that is that now you have this list of data that testers and everybody else can look as a reference point. What are we pushing from one branch to another? And that's just a bit of happiness. Now, you can customize team build in many ways. The basic orchestration, the way you're going to change this is you can customize a process template. And you can go in and add standard activities, or you can create custom activities. So we've got this kind of stepped approach to how much effort we want to put into it. One of the things they did in 2010 is they tried to expose more standard parameters in the build definition so that you could change it through the UX without having to write a custom build task or a custom activity in the new world. All these settings here that are on the screen are now checkboxes within the Edit Build Definition process tab. Right? Remember when I did the agent filtering, I just checked that. Running tests, on by default. I want to publish symbols. Put a symbol path and you're done. That's all you have to do. So they've reduced the amount of stuff that we wrote custom code for and custom processes for in 2008. That's a great thing. But if you want to go the next step, you're looking at customizing the XAML definition and possibly writing a custom activity. If you want to write a custom workflow activity, you're going to need to brush up on Windows Workflow 4. But there are samples out there, and I'm going to show you a sample you can download when you go home. And it basically breaks down, you create what's called an activity library, which is either a C# or VB.NET workflow project. It's basically a DLL. And then you go in and define the activities. And the activities can be code activities or XAML activities. You then check in that assembly, and there's a couple ways to do it. The easiest way to do it, though, is you check it into version control, and your controller will automatically be able to pull it from version control and make it available to the agent at runtime. So this makes distribution much easier. Okay? On my machine, I just put it in the GAC and made it available that way. Now, doing this, Well, why? Well, you might have some customization things that you need to do, encapsulate and reuse operations, right? Deploying to a web server, deploying to your custom deployment environment, building an MSI that doesn't have a supported installer anymore. Whatever it has to be, you can do. So how do you build one? Well, it turns out it's something that you can't really just do very quickly, but I'm going to show you the basic steps, and I'm going to show you the custom one that you can download. Step one is do a new project. And you want to pick an activity library. In this case, I've highlighted the C# version. Nice thing about the install templates box is I can just say activity, and this will filter down, and I can see both the C# and the VB one. So we'll call this live Mac. And what will happen is, by default, you'll have your activity here, ready to go. And then you go to the toolbox, and the toolbox is going to give you access to a bunch of built-in activities. These are all part of Windows Workflow. And so what you typically start with is you start with a sequence. Once you have a sequence, you can now say, okay, I want a condition. If this condition is met, and you come in here and enter the expression, if 1 equals 1. If 1 equals 1, then I can go over here and pick a branch to, if I was doing a branch, sorry, I can come over here and let's do collection. Right now I can start adding some data to a collection. So there's this basic workflow language that's represented in basic primitives in Windows Workflow. Well, the thing is, you're saying, okay, this is great, I can come with some logic, I can control flow, but what if I want to talk to team build? Well, turns out that if you right-click on here and say choose items and go to system activities, if you haven't already referenced it, which I haven't, you can browse out, and I think that's actually in my drop-down note. Go right there. Now I'm going to grab this path out and show you in Visual Notepad. Buried down under your program files directory, and because I'm running x64, it's program files x86, Visual Studio 10.0, Common 7 ID, Reference Assemblies, V2, you'll find the Microsoft Team Foundation build. Oh, client, sorry, this is the wrong one. That's for the later demo. Let's drop down a little further. This one. Giant path. The DLL you're looking for is microsoft.teamfoundation.build.workflow.dll. This DLL contains all of the workflow activities that Microsoft created. Okay? Now, once you do that, they'll show up on the list there, and then they'll show up in your toolbar. Now, I did a bad thing. When I added them inside one of the tabs. So you really want to create your own tab first, and then put them inside the tabs. Once you do that, you can come over and take an activity and drag and drop it in there. So now I've said I want to create a version control workspace. So you're going to go through here and basically figure out what you want to do. So step one is a pencil and paper. What am I trying to do? What is my execution flow? What are my conditions, things I need to evaluate? And then what information do I need? And what information do I want to make visible to my users? So you can come in here and you can define variables that you want to track. So this allows you to pass data from one activity to another. Right? So activities will be able to reach up and read a value to do a conditional evaluation from one activity to another. I can specify arguments that I want provided, as well as I can do imports, which is basically lets me hook into other assemblies that I want to do for runtime evaluation. So it's very powerful, but it can get out of the hand. Let's take a look at the sample I'm going to have you download. If you take a look in this activity, this one actually has 2 items in it. It has a code activity, and it has a XAML activity. Now this one has the build items defined in it, so you can see them all right here, nice and broken down. But here's the major categories that are available. Build activities, and then the lab management activities. So you can see there's quite a few. And the good news for you coming to the talk now is Microsoft has finally done some basic documentation on these now. At RTM, they didn't have anything. So at least you can kind of read that and figure out what it does. But if you take a look at what this does, update version info, it's going through, and the idea behind this activity is we want to automatically assign a version number to our assemblies when they're built. It's funny that this is not something that's built in. So that's what the activity does. It works in conjunction with the replacement files. And what it's basically doing is it's going through, getting the build information, getting the build format, and then taking that and going through and looking through all of your assembly.info, assemblyinfo.cs or VB files or other types, F#, and then we'll go and update a well-known attribute with that value using a regular expression and the replacement files code. It'll then save that and then build it. So if we go back to my little demo, just as a reminder, when we run this, notice it says 1.0.0.0 because that's the default value that all Microsoft projects in the modern era put for their assembly version number. So we want this to change. So this is what happens if I just run out of Visual Studio. On the other hand, if I run it from a build and go to my drops, notice it's got that format. And this tells me that this is the third build on the 19th of May, 2001. So the way this was done is step 1, create an activity library. Step 2, you write the XAML. Step 3, once it's compiled, you have to make sure it's available to Team Build. Now the way you do that is you go to your controllers, and you'll see there's an option here for the version control path to where it can find custom assemblies. So typically what you do is you define a location of version control where you put your custom DLLs, and they will automatically pull those down to the agents for you. Now mine's not set in this example because I put mine in the GAC. So you've got that ready. Now the last bit is, how do you tell the build process to use your custom activity in a build? Well, what you're going to do is you're going to come to source control and you're going to go to this build process templates folder. And in doing so, what you're going to do is duplicate one of the existing items, right? You do not want to edit the default one. You want to leave the default one as is. Now, and by keeping it in version control, then you have a history of it. You know what happened to it. Now, if we look at the default template, this is, on one hand, not super complicated. What it is it's a sequence diagram that gets the build, updates the drop location, runs the build on the agent, and checks in gated changes if this is a gated check-in. Those are the 4 major steps. Well, let's take a look at what run on agent does. Run on agent does 3 sequences. Initialize variables, initialize workspace, if create label. Oh wait, it does a lot more. Okay. Let's look at initialize workspace. Delete test runs if not clean, if clean. You can see where this is going, right? 30-inch, 40-inch monitor, baby. Right? They even have a little tool down here at the bottom so that you can fit to screen. Yeah. There we go, a little better. Okay? So in either case, in this case of this customization, I duplicated this file. I then went to my toolbox and I added, just like I showed you earlier, I added the activity DLL, and so I have 2 activities on there. And so what I did was, we'll collapse all. I went to run on agent, and I scrolled down, and on run on agent, inside initialize workspace, I dragged and dropped the update version info activity. So remember the package I showed you had two activities, a code activity and a XAML activity. Drag the XAML activity on, and then you'll notice that on the XAML activity, it has some properties. One is, what files do you want to look for? Well, assembly info.star. What's the regular expression? This determines the build format that you're looking for. And then the sources directory. The sources directory is pointing to a variable called sources directory. This is a variable that's available in the workflow that the activity needs so it can go find where it's to be searching to recurse through. Oops. And the version info is something that it will set as part of its process. Now if you take a look here, then you can see the variables and notice the scope. It's telling you where it's coming from, and that's where we find sources directory as a variable we wanted made available to us. Now, arguments, this lets you control what data you want surfaced in the edit build definition dialog on the process tab. So you'll note things like get version, scroll up, create label, MS build platform. All the items you see here are shown in the UX. So for this custom activity, we went and defined two, versioning file spec and versioning regular expression. So these are those properties that we have in the XAML, but we want to make it available to the user to change, right? We don't have to come in here and recompile the activity, right? So we're now surfacing them. So understand, you can have properties that are available to the XAML editor, but you don't surface them to the user in Team Build. If you want to surface them to Team Build, you add them here, and then that gives people the ability to edit them through what's called the metadata collection. Define the properties first, then go to the process parameters and expose them here. Now, when I go look at my build and go look at the process, notice I'm using the ATL template. And ATL is for Atlanta, not active template language. And now notice I have a new section called versioning. There's file spec and regular expression. And also notice that right here I've changed the format of the build number format. You'll have to look at home, but basically it's different than the default. So the workflow is figure out what you need to do that's custom, build your activity library. Check in the activity library, the version control, and tell your test controller about it. Copy one of your working XAML files and create a new version. Put your activity into the workflow, decide what variables to surface, and then you're good to go. So now with this new activity, and I run the application, we get this. And so let's go queue one up. So we should see number 4 if I queue this puppy up. And there we go. Open up drop folder. And there we go. And by the way, the warning was because it accessed it via UNC path and it was telling me I'm running something from an untrusted location. Okay, that had nothing to do with the build process. So now with that activity, you can go through and do that. And that's how you can do other things, right? You need the activity, so either you find one or you build one. Make sure the activity is available to your build agents, preferably version control, set controller path. Duplicate existing XAML file, include in the XAML, edit properties, surface properties to the build definition, and go. Now that said, you can tell that, write an activity, write an XAML, it's just workflow. So you're going to want to research workflow, or hopefully next year they'll do the session I asked to do, which is I was going to spend the whole session just building activities. But the point is, dig down into workflow, and you want to start with just generic workflow, understanding how workflow works, understanding things, and be careful, the key is workflow 4.0. Right? Things changed quite a bit from previous releases to the version that Team Build is using. Now, when you think about bringing this all together, right, all your artifacts should be kept in version control. Everything that makes up your product should be available to version control in the build process. Changes are driven by work items, so that when people check in, they associate with the work item, that gives you that running history. Right? Builds assemble artifacts and create snapshots of work completed, right? It gives you that kind of point in time. And the build reports are providing the view on that point in time, they're providing that metadata. And it's going to give you historical evidence of how we're doing. It's also how when you get to the end of a release that you can say, how do we do? It helps you with your post-mortem to look at your improvements, right? How many builds do we break on average? Right? All this stuff is published into the Team Foundation Server Cube, which means I can do great reporting. And you can even use the TFS API to go in and harvest this information from both the warehouse and the build reports to create custom release notes and documentation, right? So you're only limited by your imagination. So the bottom line is Team Build allows for consistent and repeatable builds. Remember, it lets you take the pulse of your team. How are we doing right now? Does our output create a product? Are we there yet? And it gives you something to show your stakeholders and your customers, yes, we are working on this. It's not a dream, it's not a fantasy. And use Windows Workflow and MS Build, right? That supports limitless functionality and extensibility. You can do anything you want. Slowly but surely, we have the community are building activities, and now that it's it's a year out there, we're starting to see stuff out there. So take a look at CodePlex, look at some of the MVPs. Mike Fiore, one of the MVPs out there, has some. Ed Blankenship's been working on a CodePlex project, so we're trying to add more out there, and you can learn from what Microsoft has done by poking a look at their stuff. I thank you for coming. There's additional resources. I'm going to put up I have a little note here. You want to download the sample? It's on Jim Lamb's blog. Here's a tiny URL for you, just tinyurl.com, Team Build AP. And he has an article. If you have any trouble, let me know. There's a couple things that are a little obtuse in his notes. You want to contact me, there's my email address. I'm on Twitter. You can harass me there, or give me a call. If you have any questions, we have 3 minutes. Go to the microphones, because we're recording, and I'll do my best to answer. Otherwise, when they cut me off, I will take questions up here or walk outside with you. Thank you for coming. Enjoy the rest of TechEd if you want to go.
If you do a gated check-in and then there's someone else who's checked in on top of you, what happens?
Gated check-ins are cute. So when the gated check-in's in place, it's going to take the shelf set and wait. The controller's going to wait until that finishes, and then it will pass on after it. The key is that the gated check-in is at the point in time that the check-in's done. So if I do a gated check-in and then you do it, your check-in, right, is going to be picking up my changes if they're successful. If my changes aren't successful, you're going to get it the way it was when I built, because it's queued up.
Can the build deploy and set up a Windows service?
Absolutely.
Okay. How difficult is that?
It depends on how you do it. You can do it by just use one of the built-in activities to execute a command like service util, or you can write a nice custom activity that does it. It just really depends on particularly where do you want that service to be, right? Do you want it installed and running on the build computer? One line of code probably, right? I can do it from call a command line. If I want to do it to another machine, then I've got to get the bits from that machine over there. And what I would look at is like PSEXE from sysinternals, because I can execute a remote command. So I could execute service util remotely. That's probably how I would.
Yeah, this would be a WCF service running as a Windows service.
Okay, well then you want to look at the deployment APIs. Oh, is there a question over there? I'm going to do that guy, and then I'll do you.
Okay. The other question I have is when you did the replace with file, and you wrote out the version numbers, that doesn't actually check those values back in, right? So I wouldn't.
No, you notice if I run it from Visual Studio, it still says 1.0.0.0.
So the version numbers would never really change.
Right. Now, if you wanted that, you could change the activity and actually do a check-in and push it back in.
Okay.
When you did the deletion of a build, there was an option dialog for what was going to be deleted. Can you configure those options for builds that are going to be deleted through the retention policies?
I've never looked for that. Let's take a look. That's a great question. I use the default retention policies as is on my server. So let's come over here, edit the definition. Go to retention policies. Oh, there it is. Yeah, what to delete right there. Drop down right there. You can control it right there. Sorry.
Great. Thanks.
Just couldn't remember. Oh, yes. Go ahead.
I was just curious, actually, what resources or what would be a good book you'd recommend for Windows Workflow Foundation 4?
Oh, for Windows Workflow Foundation 4. Send me an email. The reason is I don't know, I don't have one off the top of my head. I'm going to ask my partner, John Flanders, who's a WF expert. Unfortunately, John didn't write one, otherwise I'd tell you to buy his, but he doesn't have a WF4 book. So send me an email and I'll ask John what the best is.
This may be too big of a topic to ask, so I'll ask if there are resources and blogs on managing shared assemblies that are...
Let's talk.
Okay.
We have a test build that we use that we created a custom build definition that will either run unit tests or not run unit tests. And one project manager asked if our unit test build could have, what is it? I'm drawing a blank.
Well, you want to think, well, because they want to give you off the stage. Just think about it. Come on up and ask me right now, or if you can't remember, email me. But I got to tear down and everything else. Thank you again for coming. If you still have questions, come up here. I'm going to shut down. I'll walk out. I'll answer all your questions. Thanks. Bye.